we have Mike Anderson, CTO of Intlabs, and John Oram, CTO of Veilstream, here to talk to you about trends in software development in the era of AI.
Perfect. Thanks so much, everyone. This has been so good. The presentations have been so good. So as Casey said, John and I actually delivered this talk at the Prompt AI conference earlier in November this year, and Dana was at that and said, you know, this might be a really good chance to come present these topics to students as well, and
and fit it in a quarter of the time.
Exactly, yes. So we're going to do what was a 30-minute presentation in about 10 to 12 minutes. And then we're not going to stand between all of you and food, and that is the goal. So what are we talking about today? John?
Changes for an AI era, meaning we're writing software faster with AI, and how that has affected everything in the software development lifecycle.
So first thing we're going to go through, because we're not going to assume that everyone is necessarily as plugged into the day-to-day as John and I. John and I have spent the last 10 plus years building and managing software teams in startups in Victoria, and a lot of what this is based on is what we've actually seen personally managing those teams, especially in the last 2 to 3 years. So what we're going to talk about in AI, and I think a lot of students might be familiar with this, is basically ChatGPT, or the equivalence of, but how it works in the context of software development, and how it works in the context of software development in 2025 going forward. So what we have seen is a huge velocity boost in the shipping of software features due to what I'm going to keep calling automated code generation. Basically, AI is going to write your implementation code for you, and it's going to do that through Claude Code, ChatGPT Codex, GitHub agents, etc. There are many ways to do it, and what we're seeing is teams are reporting fairly significant gains, you know, like conservatively 20%. Everyone is saying basically that they're saving time using AI, but the problem is we seem to be outrunning our traditional software development practices by doing so, and there have been reports recently where even though we're all perceiving benefits, we're actually like by 1 or 2% less efficient at shipping features at the end of the day than we were pre-AI. And we have many thoughts about why this is. There are very chunky work units involved. But just to note that, we actually do see this. We ran a very unscientific test on a few GitHub repos just to see what it actually looks like. So what we're looking at here is the size of a pull request, or basically a request to merge a complete feature into, or a complete bug fix into the main branch. And we can see here around 2024, the median size of a pull request does not increase meaningfully. Ignore the big jump at the end. That was due to a large refactor. But the mean does. And what we're seeing here, and this is, I think, a fairly compelling example of this, we're seeing a large perception of an increased size in pull request due to these exceptionally large AI-driven pull requests. And so this is leading us to say, well, what patterns are we seeing? We're definitely seeing less research and more experimentation. We are letting AI take the wheel and drive us all the way to a complete implementation, and then going, was this the right approach? But the problem with that is that AI can't join our stand-up. It is not part of the day-to-day software development practices that we do. And so our code reviews, our primary defense to make sure that we are doing good software development, are under strain.
So we'll be talking about the software development lifecycle. So that's where you do the requirements gathering, as we've heard the talks before. You get to the actual implementation, and then how do you validate it? So going on, what's changed? Here we're going to talk about what shifts left and right. What I mean by that is shifting left is everything before the software being written, and everything to the right is everything after, such as testing, evaluation. And note that we are speeding up that middle part, but we're loading the left and the right. So,
yeah, and just to add on that, this is actually why we think that we're seeing that we're not actually really saving time yet, because all we really did by automating that implementation is we shifted the work left and right, and we didn't take that into account, and we're not planning for that properly.
So what we'll do here is we'll do a poll for the first few, but code quality and style, for example, we're going down the left of the list. I won't read off the entire slide deck. And we'll ask the audience whether they think that's cognitive load, whether you have to consider this more. Not its importance so much as whether you have to consider it day to day has increased or decreased.
Because of AI.
So let's get hands up if you think code quality and styling is now more important. Come on, students at least. Okay, okay. And now hands up for if you think it's decreased.
Decrease in importance? Yeah, okay.
Okay, one developer there.
Yeah, you're right.
Yeah. So the reason we think it's decreased is because we have all these automated tools, not necessarily AI, but you've got a bunch of different automated test suites that can verify that you've got your code written in a certain style. You've got a bunch of different validation steps that you can do. So version control. This is like, do you need to make sure, be cognizant of that small package unit of work that you can give to another developer and say, this is what I want to change in the main branch. So hands up if you think this is more important. Less important. Okay.
Okay, that one was harder.
So the reason we think it's less important is because we think that where the evaluation is happening, because we're pushing left and right, you're not thinking as much about that middle section and about that unit of work, and I want to talk to you about that later. Your hand was up before. Sorry, friend in the audience. No, behind. You too. Okay, so we think that basically the review is less important. The review of the software being written is important, but the code being written is needing to be evaluated later. So the actual chunk of work that gets changed, not as important.
Because again, we vastly increased the speed in which that code was generated. It is not as expensive to generate it, and it is not as large a loss if we went the wrong way and we just need to redo it.
Testing.
Who thinks testing is more important? Okay, good. That's great. Less
Thank
important? I kind of gave it away. Okay, good. There were a few people in rehearsal that are like, no, it's definitely less important. We're like, I'm going to find you.
So the reason we think that testing is more and more important, oh God, is because we're writing the software with an AI that's a black box. Now you don't actually know what's going on inside, and you need to actually get that evaluation, that rigorous testing framework that makes sure that the code that was written is correct. So how you check it in many different ways will be covered later. Architecture and design, now we're going to not poll the audience for every one of these. We think has increased importance because it modularizes the code in a way that allows you to isolate what the LLM is thinking about. And you're able to scope it down to a way that is more able to load the context of the whole unit of work that it needs to do into its brain and move along. Documentation, less important. I never thought it was important, but it's code should be self-documenting. It's now self-documenting because your AI will read it and understand it enough. But it now is less important, we believe. CI/CD.
It's worth noting, just on topic on there, we do think writing things down is very important. We're going to talk about that. But we specifically think that documentation is really changing and deprioritizing. CI/CD.
CI/CD. Okay, so this is the workflow of getting your code continuously evaluated and making sure the tests pass, and then getting that into the deployment. So continuous integration, then deploy. And very tight cycle there. This is really increasing in priority. I thought it was always a great idea before, but now it's much more important because the code iteration is a faster loop. So you need to make sure you are able to iterate on that loop and make sure the tests are actually run in an automated way, and then it's immediately deployed. Security.
It's very important.
Always important. So GitHub did an analysis here. And broken access control, so that's like what a user has the rights to see, got way up there.
So you'll notice, again, that same 2024, 2025 That blue line is broken access control issues. And again, it's because access control is hard and largely a specification issue, not an implementation issue. And we are seeing, these are real production code bases that this runs on. So we are seeing security review post-implementation very important.
Project management, how things are done, we think that's changing, not necessarily increasing or decreasing in priority, but adjusting. So that would be like how you, let's go over.
Okay, sorry.
No, skip. Collaboration. So that's, you're no longer working with another developer, you're working with another developer and their AI, you're working with your AI. That stuff we think is also changing in a way that needs to be addressed.
And we're honestly still kind of seeing it change really rapidly and hopefully settle over 2026.
So deployments and environments. So getting your stuff out there, this is similar to CI and CD, but getting a preview environment, for example, I made a bet that that's actually something that's going to be higher priority. That's what I started my company in. Deployments. Getting that stuff out there in a way where you can evaluate it in a way that is not reading over the source code, some faster iteration mechanism.
Perfect. And so now we're going to jump in and talk about a couple issues that we've noted and how to help you shift left and shift right in your software development practice. So as John mentioned, testing, if you walk away with one thing, it's that as we become less and less connected to the code that we write, verification and testing becomes more and more important. We identified a bit of a problem with this, though, and it's what we called the Matryoshka doll of verification problems. And it's sort of this nesting issue. And at the outer layer, it's that, as we said, we have more code being written by fewer people and faster. So what do? We generate tests. The thing is, though, is that tests are kind of annoying to write. They're very repetitive. It requires you to set up a lot of things. It's something that AI is pretty good at writing. And so you're going to be very tempted, and I think you should, auto-generate your tests using AI. But now we have a problem. Now you're still not very connected to your tests. And so this is something that we need people to be aware of, and this is more of a PSA. When you are writing your tests using automated code generation, being aware that it has very significant biases. It has biases towards happy path, and we talked about self-documenting code. The problem with that is if the AI reads code, tries to understand it, and write a test about it, and the code is incorrect, it will write an incorrect test that will verify the incorrect behavior. And so it's very important that you read this and you understand. It will also, in agent mode, sometimes edit tests to pass so that it can move forward instead of actually fixing an issue. Now, what we can do is we can go a level deeper. We can say, okay, well, we can give it better requirements. And we can do that, and we'll write better tests by writing better requirements. But man, I'm not that great a technical writer, and you know what's really good at writing like really clean requirements? AI. Well, again, I'm here to remind you, it's very, very good. I think you should, in fact, but there are problems with that, especially around hallucination of features. John actually has a story about that.
I implemented a feature. Didn't release it to production, it was behind a feature flag. Then I auto-generated all the documentation. My co-founder says, John, where is this feature? The documentation says it exists. I say, shit. I never shipped it. Yep. It was in the code base, the documentation was generated from it, and it shipped. So the documentation shipped, not the code.
So the core of this is, and it's the reminder, the analogy breaks down a little, but basically the core, the smallest Matryoshka doll has to be you. You have to remain as a human in the loop. We don't necessarily think for all of the implementation, but you have to remain a human in the loop for all stages of that verification pipeline. That is the trade-off, and you have to get good at that, but if you are, you will see a speed up. Now with that, we have some tools and practices to help you with this. So one of the things that we want to impress upon students, especially as we're seeing more automated code generation, is to really try and push back against the traditional way of mentoring that we're seeing right now in industry, which is through code review. That's how many developers will impart sort of wisdom on how to improve. The reality is, if you didn't write the code, there's not a lot of value in you participating in a review of that code. And so we would like to propose that instead of code reviews, we bring back pair programming. You probably heard about that in your classes. And we're pushing on the industry side to bring that up. We want to do that. We also want to move more away from technical reviews and into functionality reviews, bringing in stakeholders from different parts of the company. QA, product owners, sales, they should all be involved in these functionality reviews, and they can be involved earlier because the code is shipping faster, and we can spend that time making sure we're verifying and doing things right. Finally, just something to remember, and this is for the remainder of the tools that will help you, is an important acknowledgement of how these systems work. They are stateless. Humans are stateful. When we make a mistake, when we push an issue to production, we learn from that. We try not to make that same mistake again. We embed that in our knowledge going forward. Unless you explicitly do that with an AI system, it will continue to make the same mistake over and over again because it has no inherent state. So, to help with that, and this is a big one, we think it's very important that you get very explicit with a shared source of truth. This means that your project documentation should be in repo or accessible via MCP, and you should write down all of your learnings in deep dive docs so that they're available to your team members and to AI. There are other tools. I'm going to fly through these. We can talk about them during the networking, but basically the more automated tools that AI has access to in development, the faster you can catch a lot of issues. Automated formatting, automated test execution, automated vulnerability scanning. The more you can do that up front, the less likely you're going to have an issue at the back at the end of the review.
Preferably you're pushing left than pushing right.
Exactly. Now, finally, we talked about this writing documentation. Here's the thing I want all the students in the room to understand. You need to get very good at writing specifications. This is something that traditionally we haven't spent a lot of time on because we do a lot of collaborative work, and that is changing. Luckily, the nice thing about writing a spec for an AI is that it's basically exactly the same as writing a good spec for a human being. So if you improve this skill, you will be able to prompt better and you will be able to generate better automatic code. Finally, and this is what we talked about as well in deployment, we still think you're going to make mistakes. We still think there's going to be issues with code and we're going to break things because we're moving fast. And so a good solution here is to just limit the damage when you can. And so for that is learning about feature flags, building really nice composable things that can be hidden and rolled out gradually, and as well, when you're developing, have the ability to create ephemeral test environments so that you can rapidly test with your whole team and uncover bugs more quickly. So with that, hopefully we stayed within time. We'd love to stop for any questions if we do have time, and thank you very much.
Questions? Any questions?
We can take one more question. Yeah.
One question. Okay.
We have time for one question. Does anyone have one question? Maybe not?
Oh, we were
Small
good.
food?
No, everybody figured it out.
Okay. Oh, we do have one question. We got one question in the back there.
Yeah. So you mentioned how AI improves speed, but also now there's more of a security risk. So how do you balance that and find a boost to productivity while staying secure?
So the question is for anyone who didn't hear, and just to restate, we're seeing more and more security issues now that we're pushing code faster. How do we balance security with that moving faster? So there's no fully right answer to this. It is a trade-off, and that's what we were kind of showing is that because we're using our existing practices to manage a lot of this AI development, that's why we're not really seeing in 2024 and 2025 that speed up of gains that we get from much, much faster code development, because these practices that we use to verify for security, verify for correct spec are still slow. So if you take one thing away, it's if you build that muscle, you take all that time that you saved with writing features, and instead of going okay, well, I'm just going to write 1 million more features that are just going to slow us down in verification, you take that time you saved and focus actually on writing good specifications, on collaborating with your team, on doing good verifications, which frankly you never had time for before, but now you do, you will, I think, actually ship a better product at the end of the day.
And to answer, in my context, my front end is entirely written by an AI. My API, and it only ships API keys to the front end every once in a while. The API inside that it's talking to, I have very strict code review process, and I make sure that it doesn't publish API keys to the front end. And then anything that's in the accessing customer data, AI doesn't touch, only me. And that's heavily tested. So evaluation of where you put your time and where you allow the AI to play.
Thank you very much, both. As someone who teaches requirements engineering and about understanding what you're building and functionality you try to build in, I am immensely grateful to Mike. He took my course, requirements engineering, about 10 years ago, and whenever I ask him to come talk to my students, he always says yes. Thank you so much, Mike. And any one of you who go in the industry and you want to come back to us and teach our students, please do so. We'll be grateful. Thank you.